Okay, somehow, I don't know, the video got cut off here. So anyways, I divide by -1, and then I get this. Now, this, we go back to this. You see, x was either 4 or -4, right? So this whole quantity was either one of these. So this whole quantity, it's either 8 or -8. And then we solve for q. So subtract 4 from both sides. You get 3q equals 4. 3q equals -12. And then divide by 3, and these are your two solutions. Okay? All right, so that's enough for absolute values. Let's go to the last section, section 1-5. And solving quadratic equation, because that's an important section. You can solve quadratic equations by different methods. One is called factoring. So first of all, what's a quadratic equation? Quadratic equation is usually written in this form. And we call it quadratic because the degree is 2. When the highest exponent is 2, we call it quadratic. If the highest exponent was 3, we call it cubic, and so forth. That's called standard form. The other form, which is called the vertex form, looks like this. Y equals to, sorry, let me write it again. Y equals to a x minus h squared plus k. We will get to that form. You will see it. But let's look at this form first. So the first problem I was going to try, which uses the method of factoring, is number 20. We get this. This is on page 125. Okay, so I want to put it in this form first. So I can move the n squared to the left side. Sorry, let me backtrack. We are solving for n. And we want to, this is a quadratic equation, the degree is 2. So we are solving for n. And one of the methods I can use is factoring, which we did last week as well. So I can move the n squared to the left side, but I'm going to have a negative n squared. And for factoring, it's easier to keep the leading coefficient positive. So actually, I'm going to move the negative 10n to the other side. So I'm going to add 10n to both sides. And I'm going to put it in that order. So these guys cancel out. I get 0 n squared plus 10n plus 25. And I put the 10n in the middle, just like this one. You see, this is n to the power of 1, x to the power of 1. That's the middle term. Okay, so factoring. Put two parentheses. How do we get n squared? We have n and n. If you have two pluses, we put two pluses. Remember that table of signs that I gave you last week. And what are the factors of 25? Well, I can write it on the side, 25 times 1 or 5 times 1, 5 times 5. Which of these two pairs can give you 10 when combined? Obviously not 25 and 1, because that can give you 26, or that can give you 24. But 5 plus 5 is 10, so it doesn't matter where I put them. They're both pluses, so I put that. Now, we use the zero product property that we discussed last week. That means we set each term equal to 0, and we solve. And this just happens that both solutions are exactly the same, so n equals -5. So we solve this quadratic equation by the method of factoring. Okay, let's go to problem 53. And I'm going to modify 53 a little bit. So this is not exactly 53, just a little bit. So I'm going to add x minus 3. You have x minus 3 squared. In the book, it says plus 7. I am going to make it a minus 7. So this is not exactly 53. It's not exactly 53, sorry. So I want to isolate this. So I'm going to add 7. Gives you 9. Now I'm going to use square roots. That's another way of solving quadratic equations. You're going to use square roots. Because I want to get rid of this, so I'm going to take the square root of both sides. There you go. Why am I taking the square root? Because you remember power over the root, they cancel each other out. So you get x minus 3. And what's the square root of 9? Now, remember, when we were solving equations last week, I said if you take a square root when you're solving an equation, you always put a plus and a minus 3. So square root of 9 is positive and negative 3. Okay, and then add 3, x equals. Now, be careful. You have two options here. You have positive 3 plus 3, and you have negative 3 plus 3. So that's a negative 3 plus 3, positive 3. So x can be 6 or x can be 0. So these are your two solutions. So we solved the equation, this quadratic equation, by the method of square roots. Okay. Now, the next method that we're going to use is called completing the square. And that's one of the handouts that I uploaded on Moodle that looks like this. Completing the square. Let me see if I can zoom out a little bit. No, I can't. Okay, I'm zooming in. Okay, but that's okay. So this is completing the square. So the first thing the first step is leading coefficient must be a positive 1. So, excuse me, we're going to try number 66. 66 is n squared equals to 4n plus 10. So the first thing I want to do, then we are solving this equation for n using the method of completing the square. I'm going to put it in the standard form. So I'm going to subtract 4n and 10 from both sides. They become negative 4n, negative 10. So the first thing is leading coefficient must be a positive 1. Is the leading coefficient a positive 1? Yes, it is, because that's 1 already. If it wasn't 1, a positive 1, then I would divide both sides of the equation by that number to make it into a positive 1. Okay, so we're done with step number 1. Step number 2, move the constant to the other side of the equal sign. So what's your constant? Negative 10. Move it to the other side. That means add 10 to both sides. Cancels, so you get n squared minus 4n. Leave some space here because you're going to add a number. 0 plus 10 is 10. Okay, step number 3. Add quantity b over 2 squared to both sides. So what is b? Well, b is the coefficient in front of your variable with a power of 1. What is the coefficient in front of our variable with the power of 1? You see, this is n to the power of 1. So what's the coefficient in front of it? Negative 4. So I'm going to take negative 4 divided by 2, b divided by 2 squared. So what's negative 4 divided by 2? That's negative 2 squared, which gives you positive 4. So you're going to add that number to both sides of the equation. Okay, so obviously that gives you 14 on the right side. Next step, factor the left side. So I give you a shortcut. The whole thing is called completing the square. That means the left side will become a perfect square. When you have a perfect square, you can show it as a parenthesis to the second power. A perfect square means, for example, you have x minus 2 to the second power, like that. Okay? So you put your variable, whatever your variable is, and then whatever number you got here when you were calculating that quantity before squaring it, whatever number is here before squaring it, you put it right there. So it was negative 2. Okay? Next, take the square root of both sides. Why? Because we have a square and it's isolated. So it's just like this problem we just did. So we take the square root to get rid of the square. You get n minus 2. These guys cancel each other out. Power over the root. And I'm taking a square root in solving an equation, plus or minus square root of 14. Now, 14 is not a perfect square. That's why I'm not going to take the square root of it, because I'm going to run into decimals. So I'm just going to leave it as it is. What's the last step? Add 2. So n equals to 2 plus or minus square root of 14. Now, I can't add 2 to 14 because 14 is under the square root. So here it is, my two solutions. 2 plus square root of 14, 2 minus square root of 14. Now this is a shorthand way of writing it. You can split the two solutions apart, but we still have two solutions. Okay? All right, so that was solving a quadratic equation by method of completing the square. Now let's solve a quadratic equation by method of quadratic formula. So if we have this equation, ax squared plus bx plus c equals 0, and if you complete the square on this, you get the quadratic formula, which is this, which I'm sure everybody remembers, the good old days. So you don't have to worry about completing the square on this equation to get this formula. Just remember the formula. So we're going to jump to problem 93. 93 is this equation. And does it look like that? Yes, it does. It's in standard form. One side equals to 0. So one side has to equal to 0 in order for you to apply the quadratic formula. What am I solving for? I'm solving for m. So my x is actually m now. So m equals. Now, what is my a? What is my b? What is my c? Well, a is my leading coefficient. If your equation is in this form, then a is your 3. B is negative 7, C is negative 6. So just plug them in. So you have negative B, so negative times B, but B itself is negative, plus or minus square root of B squared, so that's negative 7 squared, minus 4 times A, what's my A? 3, times C, which is negative 6. Make sure your radical sign covers the whole thing, and the fraction line. All over 2 times A. What was my A? 3. So that's the setup. Now we got to simplify. Okie dokie. So we have m equals 6. Negative times a negative is a positive. Plus or minus. Negative 7 squared, that's negative 7 times negative 7. That's positive 49. That's negative 4 times 3. That's negative 12. Negative 12 times negative 6 is 72. So positive 72. You add 49 to 72, and that's 121. Oh, sorry, square root of 121. Oopsie. So what's the square root of 121? That's a perfect square, which is 11. So square root of 121 is 11. Fortunately, no decimals. Okay, so we have 7 plus 11 over 6, or we have 7 minus 11 over 6. Two solutions. 7 plus 11 is 18 divided by divided by 6 is 3. 7 minus 11 is negative 4 over 6, which gives me negative 2/3 when I reduce it. So that's one solution. That's my other solution. How are we doing? We're good? So that was an example of using quadratic formula to solve a quadratic equation. Okie dokie. Let's move on to problem number 116. Okay, so before we do that problem, we're going to talk about something. This portion of the quadratic formula, just the b squared minus 4ac, is referred to as the discriminant. And it can help us in predicting what type and how many solutions does your equation have. It will not give you the solution. It will tell you how many and what type you will have. So if your discriminant is greater than 0, you will have 2 real solutions. If your discriminant is 0, you'll have 1 real solution. And if your discriminant is less than 0, that is, it's negative, then you have no real solutions. You're going to have imaginary solutions. And the reason is obvious, because if this quantity is negative and you have a negative under the square root, remember last time I said if you're taking a square root of a negative number, you will get imaginary solutions. You don't have real solutions. So that's why this will give you no real solution. So based up on that, let's look at number 116 on page 125. On number 116, you have 9x squared plus 4 equals 12x. And it's asking you, the direction says, use the discriminant to determine whether the given equation has irrational, rational, repeated, or non-repeated roots, non-real roots. Also state whether the original equation is factorable using... that's too much mumbo-jumbo. Okay, let's just do the discriminant. Okay. So first, you want to put the equation in the standard form. So 9x squared minus 12x plus 4 equals to 0. So you subtract 12x from both sides. Okay, what's your A? 9. What's your B? Negative 12. What's your C? 4. It's not asking you to solve the equation. Just get the discriminant. So the discriminant is b squared minus 4ac. So b is negative 12, square it, minus 4 times a, which is 9, times c is 4. Okay, so what do we get? Negative 12 squared is positive 144. Oops, that's a 4, not a c. And then you get negative 36 times 4. That gives you negative 144. Haha. So what's your discriminant? 0. So if your discriminant is 0, then you only have one real solution to the equation. That's all. It's not asking you to solve. It's just asking you how many and what type of equations are you going to get. Okay. And let's do a... I would recommend you guys try problem 130 on page 126. Number 130 on page 126. And we can, if you like, we can try it during our Tuesday class. Okay? So that was the end of chapter 1. Basically working with linear equations and inequalities. And in the next video, we're going to start chapter 2. And that will be it for this week. Okay? I'll see you guys next time.